So, let us continue on with the 6v6 episode. Alright, there's the old chassis with 2 coats of etching primer on. Whilst that's drying and I'm painting that, we need to try and sort the power supply out. So in an effort to do so, instead of doing loads of calculations and all that bollocks, I'm just going to use this big transformer here to supply a power supply, power the heaters up with me handy dandy bench power supply. I can move all this freaking junk out of the way. Right, so yep, that's on. So that's providing the heaters. And so what we're going to do, what we've got basically is a bridge rectifier fuse, one 220 microfarad capacitor. We're going to have a look at that with our scope. We're going to have a look at our output with a scope. And what we're also going to do is to see how much current we've got going into this 220 mic cap. That's the plan anyway. Let's see if it works. So we're going to monitor our voltage on this meter here. I'm going to use this meter as our roving probe, as it were. So let's first see if we have got any voltage at all. Is that working? Right, no, because we haven't got that turned up. Okay, I just saw a bump there and I just saw that flashing at me. I've got 26 volts. Hurrah! So that seems to be working. Everything cushy there. Let's bung those 2 controls right down to 100 millivolts per div. Okay, we're getting obviously very little current there. Right, let's whack the heaters on. What have we got here? 6SL7, 6v6, 26 volts. Let's crank that up. You see our scope bouncing about. Our current draw is going up, 1 milliamp. Got to go up. So I'm trying to keep an eye on everything in one bloody. I'm cranking up what we got now. We've got 286 volts. We've got 4 milliamps. Really? This is AC milliamps. Really? Blah blah blah. We'll check some voltages in a minute. That's what we've got there. Let's. Right, what's that going to? Blue one. That's on a power supply. That's what we've got on the power supply. So that is very, 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 very small. That's what? Less than 10 millivolts on the output. We've got bugger all. All things are quite silent, as it were. Hope you can see that. I've got glare everywhere, so it's a bit hard to see what you can see. 292, right. Now then, our cathode voltage is what? Is it 12 volts? So we can stick 312 in there. Can't go over there. Oh shit, where am I going? Fucking mass! Honestly, it's like bleeding. I was just, pardon my French, I was just, you know, pootling about here and a frickin' mouse climbing up there. Oh, I don't want the buggers in me scopes. Yeah, right, so I best start putting some traps out. I don't mind them out there, they're already nicking all my compost and everything, but no, not in here with my test gear. No, thank you. I wouldn't mind if they cleared up after themselves, but there's shit everywhere. Right, what are we getting? That doesn't make frickin' sense, does it? 0.45 millivolts at 307 volts. We've got heaters. Have we got a voltage drop? So we use our roving probe. Okay, that's reading nothing. So what the... oh, I see what the problem is. We've got a wire off down there, look. So basically that's going to nothing. Right, no wonder we've got no current. Right, let's turn that off. Let's turn the heater voltage off. Turn the iron on. Right, we best discharge that. 297 volts, so it's just going to float there. Here's a handy dandy discharge tool. I won't try and do this two-handed. I'm just going to have to put you down. Gonna have to put you down for a while. What's the rest of it? I can't quit you, babe. So I'm gonna have to put you down for a while. Put it back where you found it, and you won't lose the bugger, will you? Right, I'll go and solder that on, and then we'll try again. Dopey bugger. Right, that's soldered on there. Let's try again, shall we? Heater on. Right. Running it on my variac to this. 9. Oh look, now look, see? That's what we should be getting. 15, 200, let's crank it up. You can see both of that. Knock it to about 300. Freaking mouse hook again, look, it's gone out. Just saw it climb out the bleeding. That's where they're getting in, look there. See, what I do, I put wedges in there so the insects can get out, but of course that lets all the bugs and beasties in. Fricker. And of course they're climbing up. Okay, I can see we've got to do some pruning. Right, back, concentrate. 38 milliamps, that's more like it. And look at that. What's that in RMS then? Let's use a handy dandy probe on AC volts to find our ripple. Okay, 0.9 millivolts on the OP, and down here 300 millivolts. So, and as you can see from this trace, that's our output, that's our power supply. So as you can see, that's no good. So we're at 0.5, 500 millivolts, so that's over 500 millivolts peak to peak per dev, and over 200 millivolts peak to peak on our output. So I've got another blah blah blah, what do you call it there? What's that called? Capacitor. 220 mic cap. I'm going to try that with a resistor in there to provide a bit of an RC filter, and for that we do need to do a little bit of calculation, so let's go and do that. Doing the sums using the old 1 divided by 6.28 times by your capacitor times by frequency, a frequency of 0 hertz in, well I put 1 in first. That gave me a 720 something ohm resistor. I popped in a 1k, put in the 1k in times the 220 mic, that gives us, I don't know, 0.72 of a hertz, so that's 3 dB down. So it should be a lot better, the ripple. However, there may be a problem in that this is a 1k resistor, so therefore it can only supply whatever. What I'm saying is there may be a problem with it blocking too much current to the output stage, because basically this has got to do, this supply has got to do 2 of these. I think from looking at it last time, where were we? About 40 milliamps, so we're going to be getting on for about 80 milliamps. So, oh, and by the way, one thing I forgot to say is that our input is grounded using one of these handy dandy plugs. So that's that sorted. Blah 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 blah. Right, let's power it up. Everything is connected, nothing falling off, nothing stupid, not going to kill myself. Alright, let's turn that down. Heater power on. Let's turn the HT up, and I'm getting no reading. Try switching it on, you peanut. 86 volts. Let's watch that top trace. I want to see if it jumps when those. Right, let's keep that up to nearly 300. I want to see if that starts to get worse when the. Oh, I've gone a bit mad there. When the 6v6s start to conduct, which I think they already are. So that looks like we've got 400 millivolts of div on the output though. Look, that's a lot less. We're quiet on there. Try and sneak in there. Turn that down so our output is a lot better. 315 volts HT. We're pulling 35 volts, sorry, 35 milliamps. Let's have a look at our ripple. Okay, that's gone down, hasn't it? That's less than 10 millivolts. So I got hiccups, 10 millivolts. Let's have a look at ripple on the output. Whoops. Less than 10 millivolts. So that's good. However, I think we may have a problem with that 1K. I'm going to have to do the sums for that. One moment. Okie dokie. I should have been able to do the sums in my head for this bugger, shouldn't I? 315 divided by 1000 is, it's 315 milliamps, so that won't cause a problem, providing power to 2 channels. The only thing now we need to have a look at is voltage drop. So how much AC voltage do we need our transformer to be to deliver 315 volts? Blah blah blah. So let's pop it on again. Blah blah blah. Turn it down. Don't forget to turn it on. There we go. Hope you can see that. A lot of glare going off, unfortunately. Sorry. Alright, come on. Turn it up. Turn it up. Turn it up. We could actually probably use a 1K2 or something like that to squash it even more. 312, 315, that'll do. Let's knock that down a tad. Righty-ho. We need to know what voltage drop we got for a start, so. Oops. So we've got A. That doesn't make frickin' sense. Right, hold on. We've got 313.5, 283. Oh right, I'm a peanut, aren't I? Right, so what was that? 313 and 282. Right, we need this. No, barely touch anything. Right, 283. We've got a probe in the wrong place. So we've got 313, 283, 7 to 90, 17, 17 and 13, 30 volts. So we're dropping 30 volts. Right, well that's going to be more, it's going to be twice that, isn't it? It's going to be 60 volts. If the current is twice, will it? I don't know. Let's have a look. Has that increased it a little bit? I think it has. Let's have a look at our... So what we got there now? 351, 350. Okie dokie. What am I doing? So a voltage ripple here, 326. A voltage ripple here. Oh come on, get the... Can't get me freaking probe to stick. Let's put it here. About 10. So it knocks it down a bit, doesn't it? That 1k resistor. Right, I've got to figure out whether our voltage drop will be twice that. 350, 315 this end, 15, 35, isn't it? So will that be 70 volts if we've got twice the current? Gonna be, in it. I will just, right, let's turn everything off. Oh, this is a pain in the arse. My legs are really giving me jip today. I feel old and knackered. Right, you can't hold the calculator for me, can you? This is the other thing. I'm just feeling a bit sorry for myself today. Everything is bloody hard work. Right. See if the things, see if the calculations bear our, where do you call it at, our actual reality. So, we reckon we've got a 35 volt drop, don't we? Right, so where do we start here? Okay. Yeah, look. Of course it does. We don't even need to do the sum. 35 divided by 1000 is 35 milliamps, right? So let's get 0.7. Oh, come on, calculator. Yes, 0.7. Right. Try again. 0.07 times by. You know what this is going to say, don't you? 1000. 70, yes. Sometimes it's just nice to verify that you're thinking in the right way. So 70 volts is going to be dropped across that resistor. 70 volts times by 0.07 equals 4.9, so that's 5 watts. So we need quite a chunky resistor, don't we? Otherwise that's going to burn up. This is probably about 5 watts, but we're going to need bigger. About 10 watts, 7 to 10 watts. Okie dokie. Right. Blah 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 blah. Does that, what's it? Right. Yes. Okay. So that means then that we're going to need a voltage here of, where are we? 350 plus 35, 385. 385 divided by 1.35. So we're going to need a winding that will give us 285 volts AC, or if we that's without losses. Sorry, that's with losses. Blah blah blah. Cancel. Blah, blah, blah. Where are we? Oh, come on. 385 divided by 1.414, 267, so 270 to 285. Okay, so that's what we need when we wind this transformer. We need 270 to 285 volts AC, capable of providing 100 milliamps, but I shall make it capable of twice that. It's got to be beefy because it's got to supply 440 mic of current, no, 440 mic of capacitance. I really ought to do the sums for that, because if we work out the joules, how much energy is in them, we should be able to work out how much current. I'm going to have a go at that, but not now. So, okay, that gives me something to aim for with this. First I might put on the heater windings right next to the primary, so we've got good regulation, and that will also mean that we've got good insulation between primary and secondary. Right, turn everything off, time for dinner. More later.